Okay, here are questions 4 and so on to the next set of the practice final. It says, which of the following statistics are unbiased estimators of population parameters? This was the sampling distributions section 6.4, if you want to go to that to remind yourself. I'll actually just go ahead and pull up the PowerPoint from that section, from the older edition of the book, where I've actually done videos before on this, and it demonstrates a really tiny population of only 3 items and does a sampling distribution of size n equals 2. So you have to find out all the possible ways to sample 2 items from a population of only 3 things in it. And it lists all 9 of them right here. I'm sorry, that is 9. All 9 of them here. And then lists next, okay, so it gets the sample, it gets the mean, and it doesn't actually create a sampling distribution of sample means, but you could read between the lines to create it. So the left side would only have a 1, a 1.5, a 2, a 3, a 3.5, and a 5. And those would be listed in the random variable column. And then on the right side would be the probabilities that are associated with them. So since 1 showed up 1 time, it would be 1/9. There's a 1/9 possibility. Then 1.5 showed up twice, it'd be 2/9, and so on. So hopefully you kind of remember those. Anyway, so it doesn't actually create a separate distribution for all of them in this example, but it does still show the main point. The point was, if you found the mean from the distribution of sample means, you'd get 8/3. If you found the mean from the actual population of 1 plus 3 plus 5, which is 8, divided by 3 items, 8/3, you'd also get 8/3. So you would see that it targets the population parameter. So you find the mean of the sampling distribution of sample medians, for example, and you see if that targets the population median. It doesn't. For ranges, you just check that, and so it just gives you several examples, 3 of which you see do target, and 3 of which you see don't target. So that's what this question is getting at. Do you remember which items are unbiased estimators? Well, the sample standard deviation is definitely not on the list. Here's the sample standard deviation. If you took the mean from the sampling distribution of sample deviations from this, you would get 1.3. But if you took the actual standard deviation from the original set, you get 1.7, and they don't match. The nice thing about that, though, is the central limit theorem says that when you're doing a sampling distribution of sample means, that you'll find that that sigma sub x bar, so the standard deviation of the sampling distribution of sample means, will not match the actual expected standard deviation, but it will be only off by a quotient, dividing by square root of n. Anyways, that's for another question which will come up later. But so it is predictable in that case. So number 1, no. Sample range, no. Sample proportion, yep. Proportion. Sample variance, yep. Median, no. And mean, yep. So that's what that question is getting at, number 4. Again, you might not get these same questions when you're doing the practice test. So you're going to see some that address those same areas, but not the same. Here we go. So here is my chance to make one of these tables all the way down, bring it all the way to this point. So the nice thing about this is, since I have the data, I can open it in StatCrunch. When it wants to open. And they are dealing with an original population that also only had 3 values, and they are also only using a sample size of 2, so we're going to do all the sampling distributions of size 2. Here are the samples numbered, which I don't really need that. And then here are the samples. So let me do, we hit stat, summary statistics, and rows. And this will give us the chance to do all of the statistics row by row. Okay. This is, if you haven't seen my other videos, which by the way, I have an entire video on this exact same problem from when we were doing it in section 6.4. If you haven't seen the other videos, for some reason StatCrunch now behaves a little bit awkwardly from time to time, and so I just click somewhere in some other cell before I go to hit the menus, and then it won't keep bouncing out of the window. Okay, summary statistics, rows, there, see now it didn't bounce away. And I will choose the 2 items for each row, so in this first row I want those 2 items, and then it'll understand for the second one I want those 2 items, and the third one those 2 items, and so on. I could have in fact deleted that whole sample column. And I am trying to find the, let's see, variances here. So I don't need all this other stuff, I can just do variance. And I can actually store it all back in the table, so I'm going to go ahead and do that. Okay, so it says row variance, and it has them all listed here. Now I can relist them as s squared, and I don't need to restate a sample variance if it's already been stated, so I don't need to duplicate my statements. So I've got a 0 that shows up, I've got a 5/10, next one 12, no, next one 8, 12.5. Let me just see if I got all of them. Right, and then I didn't repeat them for duplicates, which by the way, it makes sense because I'm going to have 1, 2, 3, 4 distinct different variances here, and so I've got that here as well. All right, so then what's the probability, because I'm creating this probability distribution here, what's the probability that you could have a 0? Well, out of the 9, there were 1, 2, 3 of them, so that's 1/3, and I'm going to put 0.03, and I'm just going to hold that for a while until my finger gets tired. Okay, and then so 3/9 for that one, and then for the 0.5 there's 2, so 2/9, which is the same thing as 0.222 forever. Okay, there's 2/9. 8 showed up 1, 2 times, so that's 0.222 forever. And I want to be really accurate, that's why I'm going forever on these, well, until my finger gets tired. Okay, there we go. If I want to double check that I've actually created a probability distribution here, I need to verify the requirements for it, and one was that each of these themselves were probabilities, meaning that they fell between 0 and 1, and these all do, right? That these things occurred by random chance, well, they did because we found all the sampling sizes of size 2, so there's your your randomness, or at least your expected randomness, right? And then all of these are supposed to add up to make 1 if it really is a probability distribution. So I'm going to add up 0.3, and I thought I could hold it forever. I guess I have to use the keyboard. Okay, plus 0.2 plus 0.2, and again. It equals 0.999999 forever is equivalent to 1, and that's kind of fun little proof to see. So anyways, that isn't just close to 1, that is 1, because these 99s are supposed to go on forever. If I would have added it in fractional form, it would have looked a whole lot better, because it would have been, let me see if this calculator allows me to do that. It would have been 3/9 plus 2/9 excuse me. There's your 1/3 right there. Okay, so if I would have added in fractional form, it would have looked better. So let me fill that in actually. 0 for this one, and it wants an integer or fraction, so I'm going to go ahead and leave it in fractional form. 0.5, what do we have over here? 2/9. I am suspicious that if I would have put in enough 2s or enough 3s, it probably would have still treated it like it was the same thing. But why play around? Okay, so we're going to, again, it's not homework, so I can't enter it yet. We're going to go ahead and assume that we did that correctly and read through the rest of the question. Compare the population variance, oh, okay, all the way back up here to the original population, with the mean of the sample variances. Okay, so I haven't actually found out the mean of this, right? To do that, I need to remember this formula here that says to find the expected mean, you add up all of the random variables times their corresponding probabilities. So let me go ahead and just set that up. I'll call this one S2, I already did that. I'll call this one P of X. And then I need to multiply them all together and add them, so I'll actually rename this as S squared sample variance times probability, corresponding probability. Oh, you know what's dumb about my labels there? It should have the same label there if that's my random variable. There we go. So the variances, sample variances here, their corresponding probabilities, and then this is going to be the list of all their products, which I can find by doing data, compute expression. I'm going to build the expression out of those pieces. So this, put it in, times this, put it in. I could have typed that, I suppose. Hit OK. And then the label, well, I've already got a label up there, so just put it over. And it decides to scoot it over. That's fine with me, I don't care. So here are, I'll just go remove this. So here are all of the products I need. And then I need to add them up. So I guess I'll just get this out and add them up. 0, I don't worry about. Then I've got 0.1 forever, 1.7 forever. This has a shorter display length. This one has a longer one. That's 1.7 forever. 2.7. Hit enter. 4 2/3. Okay, that is what I got when I found the sample variance, the mean of the sample variances. I got 4 2/3. Now I haven't actually calculated the variance from this, but I want it to be the population variance. So because it says population variance. So I've got to do that. It's not the exact same calculation as this one from chapter 3, because this is sample variance, but it's going to be the one where there's a capital N down here and a mu right here. And go to page 101. That's where we first learned it in chapter 3. So I'll calculate that, but I'm going to do it the easy and lazy way of just going ahead and opening here an Excel spreadsheet, taking my population numbers 4, 5, 9, and then saying population. I think it starts out with standard deviation. Oh, I'm sorry, variance. Var P calculates the variance based on the entire population. Good. So that's the one I want. I'll hit tab and then select my array. And I can close the parentheses or just hit enter. enter. So I get 4.666666, which was no surprise. Actually, if you watched my other video, we talked about this old topic that, and I'll scoot in here just a little, that there are some unbiased estimators, and those are the mean, the variance, and proportion. So the fact that the mean from our sample variances from that distribution that we created matches the population variance is no surprise. Okay, so compare them. Population variance is equal to the square root, no, the population variance is equal to the mean of the sample variances. Yes. Do the sample variances target the value of the pop? Yes. In general, do sample variances make a good estimator? Yes, they're unbiased. So really, you should do this question that I'm doing, number 5, with number 4. Oh, you know what I just realized? It wasn't in my old video, it was in this video. Sample variance target population. Yeah, there we go, A. Wow, these videos seem to get a lot longer than I expect them to be. Let me do another one, and then maybe we'll start another video set after that. Yeah, I can do more of these. Okay. So this time just pause if you need to. I'm going to do pretty much the same process here. Stat, summary statistics, row by row. These are my 2 rows. I only need the sample standard deviations, so right here. Incidentally, this is assuming that they're samples because we're doing statistics, right? So it doesn't say in here sample standard deviation because it has to be a sample standard deviation since it's a statistic. So when it calculates with the formula, it calculates with this formula, right? N minus 1, x bar, all that stuff. Okay, so I'll store it in the data. I'll store it in the table. I will create. I'm gonna go ahead and start doing this in segments, so you'll just see me going through each part. I've created the new list of unique sample standard deviations, and here are their corresponding probabilities. Okay, and then I want to create the products. So here's the list of their products. Then I want to add all those up. For accuracy, here's a little trick I think works. First one's 0, so I really only have to add 3 items. I double click on it, or triple click, whatever the case may be. Hit Control C or Command C if you're using a Mac, and then Control V into the calculator that I'm using. So that's 1, and I'll just do that for all 3. Just keep pasting them in. So I pasted them all in, and I got 2.19 blah 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 blah. In fact, I will paste that right there and say that that is the mean of standard deviations from this sampling distribution. So it's the sum of all those. Okay. It asks me this time, it's a little different. It asks me for the population standard deviation in the beginning. So with numbers 2, 4, and 9. Well, since I already have that sheet up, I can just change this to 2, 4, and 9. And this tool was already calculating the variance. I could just take the square root of that number. And I could take the square root of 8.6 blah blah blah. Or it also has the ability to just do STDEV, standard deviation, right? So I can just use that. And then I gotta delete this extra stuff. And that is the square root of the 8.6 whatever. Okay, let me copy that, paste it. It wants 3 decimals. So I'll give it what it wants. Let me go ahead and type all this in. I wasn't paying attention to the directions here as I typed them in. It actually said to use simplified fractions. I didn't, but I'm actually I ran a whole bunch of digits, so I'm actually thinking it's going to allow me to get away with this. And let's see. Then we've already done this. This was 2.1 whatever. So this is the interesting notation where it's saying sigma bar, because it's talking about the mean, that's the bar notation, right, of the standard deviation, of the sample standard deviations. We use different notation on when we were doing the actual section, but this makes sense to us as well. It's saying what is the mean of this sampling distribution of sample standard deviations, and they only want it out to 3 decimals. So that would make that go up, which would make that go up, which would make it a 2. Now we look and see, here's the population standard deviation, 2.94. Here's the mean of the sampling distribution of sample standard deviations, it's 2.2. They don't match, and that's not a surprise because sample standard deviation, here's the distribution, here's the mean, here's the population one. We've seen that in example after example. They're not going to, because it's a biased estimator. So the sample standard deviations do not target the population standard deviation, therefore the sample standard deviation. The sample standard deviations are biased estimators. Yeah, I think that's the first one. I think I want the first one there. I'll just do a quick check before I enter these 3 answers. And then let me submit this, see if I made any errors. Okay, so we answered questions 4 through 6 this time, 4 through 6. Again, there's no issues to talk about. All right, I know these videos are going long. You don't have to watch them again. Watch them if you need them. Otherwise, just move on.